It definitely happens. All right, so we're looking at 5.1 on the review. 5.1 is the basics of... What is this? What is 5.1? What is the title of 5.1?
I don't know. Mine are labeled. So.
Bro, we should make your test.
Man, I spent the first 45 seconds of this video.
Layla. Sorry. Hi, cutie.
You know I'm recording, right?
What?
What?
I could have said so much worse.
Yeah. All right, so this is discussing nth roots and radicals. That's the title of 5.1. I don't know that was super helpful. All right, so what is the value of each expression? Round to the nearest hundredth if necessary. So the way I'm going to break this down, and I'm going to speed run this, I'm going to give myself some space on this page to go through all these problems quickly. So problem 10 says the fourth root of 16 squared. Several ways we can go about this. If I did 16 squared, I'd have to figure out a number times itself 4 times that equals, what, 256 or something like that. Not doing that. So I could rewrite this as the fourth root of 16 squared. And the fourth root of 16 we know to be 2. So 2 squared is 4. If you had chose to use our properties of exponents and switch this from radical to rational exponential form, the fourth root of 16 squared would be 16 raised to the 2/4 power. 2/4 reduces 16 raised to the 1/2 power, which is the square root of 16, and we know that to be 4. So, however you go about this problem, trust yourself, try it, and you should end up getting there. All right, problem 11. We have negative cube root of 25 to the 6th. Gross. That's real gross. Since I don't know the cube root of 25, and I really don't feel like multiplying 25 times itself 6 times, what I'm going to do is switch this to exponential form. So we have negative 25 raised to the 6/3 power. Now, 6/3 reduces to 2, so this is negative 25 squared. Now, that exponent is attached to the 25. It's not attached to the negative, so when I squared 25, I'll end up with negative 625. That's probably wrong.
That's right. That's what I have.
It is right? Okay. Woo! Good.
Except I used Jocelyn, so I don't know how.
Not mad at it. Not mad at it. You can just throw it in a calculator. 25 times 25, you're good. So, problem 12, we're looking at the cube root of 27x to the 12th. So, I look at the numbers first and the variables second. The cube root of 27 is 3. The cube root of x to the 12th gives us x to the 4th. Now, again, I'm just dividing these exponents, right? Just as we did here. Right, 6 divided by 3 got us to the 2. 12 divided by 3 gets us to the 4. And that's it. That's all she wrote. Problem 13. We have the fourth root of 16, a to the 24th, b to the 8th. Good news. We already know the fourth root of 16. She is a 2. A to the 24th. So the fourth root of a to the 24th. 24 divided by 4, I believe, is 6. So we get a to the 6th. 8 divided by 4 is 2, so we end up with b squared. All right. And we got a couple of equations to solve. Now we want to get the variable isolated first, right? So here on 14, we have 750 equals 6y cubed. I have to isolate that y cubed first. So the operation between 6 and y cubed is multiplication. How do we get rid of multiplication? With division. So we're going to divide both sides by 6. 750 divided by 6, I believe, is 125. And that is equal to y cubed. Now to get y by itself, we're going to cube root both sides. So we take the cube root and the cube root. So 5 is equal to y. Since this is an odd index, right? The number 3 is an odd number. An odd index, I only need the positive principal root. All right, so taking a look at problem number 15. We have 1280 equals 5z to the 4th. Now, the operation between 5 and z is multiplication. We get rid of multiplication with division, so dividing both sides by 5. 1280 divided by 5 is a mystery. Thank you. Hey, there's your 256 we talked about earlier. Z to the fourth. All right, to get z by itself, we take the fourth root of both sides. That's why I had to start putting a stripe in the middle of my zebras.
Have you tried to differentiate Jocelyn's Y's and 4's?
Yes, and they're pretty much the same thing. Now, what number times itself 4 times is 256? 4. So the principal root, the principal fourth root of 256 is 4, but the index here is even. So since we take a root in the process of solving an equation, when we take a root with an even index, we always end up with a positive negative principal root. All right, so there's 5-1. Roll it over, Smokey. All right, 5-2. Oh, what is 5-2 titled? Properties of exponents and radicals. So we have properties of exponents and radicals. Our properties of exponents, that's these guys here, right? That laminated sheet that should be on your desk. And the properties of radicals, we only have 2 properties of radicals. So, property number 1 with radicals. The square root of something times something else is the square root of the first thing times the square root of the second thing. It's not constant. The other one is the quotient version of the product rule. So the square root of x over y is the square root of x over the square root of y. All right. So that just tells us that I can split up my radicals if we are multiplying on the inside. Okay. Now, let's get some work done. Making space. Speaking of space, we get to talk to a quantum physicist on Friday. It's going to be a lot of fun.
Are you gonna come to the play Friday? You know, I'm gonna be like by myself
Sunday afternoon.
for her and me.
You're going to be great. You're the best at it, so. Here we
I
go.
haven't showed up to a single rehearsal yet.
Oh, yeah, so they're probably not going to do that. Square root of x to the 6th, y to the 4th, times the square root of x to the 8th, y to the 6th. Like with a lot of these problems, there's multiple ways of doing it. But I'm going to use the product property radicals first. All right, I'm going to go from 2 radicals being multiplied to 1 big radical with everything underneath. So here we get the square root of x to the 6th, y to the 4th, times x to the 8th, y to the 6th. And now I'm going to look at my properties of exponents. The same base, when I multiply my bases, right, I'm going to add the exponents. So this gives us x to the 6th times x to the 8th is x to the 14th. Y to the 4th times y to the 6th is y to the 10th. And now the square root of x to the 14th is x to the 7th, right? 14 divided by 2. A naked radical has an index of 2, so 14 divided by 2 gets a 7, and 10 divided by 2, oh my gosh, is 5. All right, number 19. We have the cube root of 243m to the 4th over 3m. Now, it might be tempting to take this problem and split it into 2 cube roots, but I caution you there, because 243 is divisible by 3. I know that because 2 plus 4 plus 3 is 9. And if 9 is divisible by 3, then 243 as well is divisible by 3. So 243 divided by 3. Perfect. So we get the cube root of 81. And m to the 4th over m is m to the 3rd. And now I can take a look. Do I know the cube root of 81? Oh, no. So how could I rewrite 81? What's the prime base of 81 is what to what power? 3 to the 4th. So we end up with the cube root of 3 to the 4th, m to the 3rd. Now, as we've been doing, right? I'm taking my exponent and dividing by my index. So my exponent here is a 4. For the base of 3, my exponent is 4, the index is 3. So 4 divided by 3 is 1 with a remainder of 1. So that means that 1 3 comes out, and a remainder of 1 3 will stay underneath. M to the third, so 3 divided by 3 is 1, so the cube root of m to the third is just m. And we still have 1 3 left underneath that cube root. So 3m times the cube root of 3. All right, problem number 20. Here we have the cube root of 5x to the fourth times the cube root of x squared times the cube root of 25x cubed. Property of radicals says that I can take all three of these, since they have the same index, matching index. I can take all three of these and get it into one radical. So 5 times 1 times 25 is 125. Oh, that's not a negative. Nope. X to the fourth times x squared times x to the third is x to the ninth, right? 4, 5, 6, 7, 8, 9. Now, the cube root of 125 is just 5. And the cube root of x to the ninth is x to the third. 9 divided by 3 is 3. Bless you. Then we have problem number 21. Okay, we have the square root of 98 a to the 10th over 2a to the 4th. Similar story to 19, right? So what we did earlier. You could split this into two radicals being divided, but I don't know the square root of 98 and I don't know the square root of 2. So let's simplify inside the radical first and then see if we can simplify there. So 98 divided by 2 is 49. Yeah, this is still underneath the square root too. Alright, so let me get that in there. Well, 100 divided by 2 is 50. And since 98 is 1, 2 away, then 50 minus 1 would be 49. Alright, a to the 10th divided by a to the 4th. A to the 10th divided by a to the 4th is a to the 10 minus 4. Right? And 10 minus 4 is 6. So we get x to the 6th power. Oh, a to the 6th power, excuse me. And now, do I know the square root of 49? Sure. She's a 7. And the square root of a to the 6th is a to the 3rd. Okie dokie smoky, number 22. Here we go. Now we're multiplying, okay? And we got the square root of n minus the square root of 7 times the square root of n plus 3 square roots of 7. All right, so I have a binomial times a binomial. So the structure of multiplying these out has to use the FOIL method. The square root of n times the square root of n is the square root of n squared. Let me get some scratch. So I'm going to do a lot of scratch paper here, scratch work. The square root of n times the square root of n is the square root of n times n, which is n squared. And the square root of n squared is nothing more than n. Right? So here we get n. Now the square root of n times 3 square roots of 7. That's a positive, so I'm saying plus. The 3 is out front. The n is underneath and the 7 is underneath. So the 3 comes out front and the 7n stays underneath. Similar story to negative root 7 times root n. That's a negative times a positive, so it's negative. And we get the square root of 7n, right? The 7's underneath the radical, the n's underneath the radical, so we multiply them out. Now, negative times a positive is going to be negative for our last term here, and then we have the square root of 7 times 3 square roots of 7. So the 3 is out front, stays there. 7 times 7 is 49. So 3 times the square root of 49. Square root of 49 is 7, and 3 times 7 is 21. So we get minus 21 here. Now we got to check, do we have like terms? 3 roots of 7n minus 1 root of 7n is 2 roots of 7n. So yeah, I can combine these like radicals. So we have n plus 2 roots of 7n minus 21. All right, 23, we have 9x plus root 2 and 9x plus root 2. Yeah, there you go. I thought it was a plus and a minus there. Those would be conjugates, but these are not conjugates because they have the same sign in the middle. All right, multiply it out. 9x and 9x, we get 81x squared. 9x times the root 2 is a positive 9x root 2. A positive root 2 times 9x is a positive 9x root 2. And the square root of 2 times the square root of 2 is the square root of 4, which is 2. Do I have like terms? So the variable radical exponent combination is the exact same with x root 2 and x root 2. So if I have 9 x root 2's plus another 9 x root 2's, that gives us a total of 18 x root 2's. I have no other like terms, so we're done. Problem 24. We got a 5 root 3, oh my gosh, plus 6, and a 5 root 3 minus 6. These guys are conjugates. Same exact binomial, except the signs in the middle are opposite. So I'm going to use our shortcut. A plus b times a minus b is a squared minus b squared. All right, so the first term is 5 root 3, and the second term is 6. So using our scratch here, what is 5 root 3 times 5 root 3? Well, 5 times 5, our out front numbers, gets us 25, and root 3 times root 3, oh my gosh, that's the square root of 9. Square root of 9 is 3, so we get 25 times 3, which is 75. Can't believe I put a scratch in my paper. Biscuits. 75 minus 36 is 39. All right, quickly we'll run through 25. We have the cube root of 4 times 6 cube roots of 2 minus 1. A monomial times a binomial, you distribute. Cube root of 4, cube root of 2
Mrs. Haley's third hour is going to Mrs.
is the cube root of 8. 1 times here is the cube root of 4. The cube root of 8 is 2, so 6 times 2 minus cube root of 4, 12 minus the cube root of 4. Oh, you couldn't even see it. That's hilarious. My bad, chat.
Good job.
We'll finish the rest later.